Hello everyone, it's Miss Thomas, and today we're going to look at rational exponents. So if you think about rational numbers, in the sets of numbers, rational numbers are the set of all numbers that can be written as A over B, where A and B are integers and B cannot equal 0. You have 0 in the denominator. Okay? So really rational numbers are fractions, or anything that can be written as a fraction. So it's your 2, your 1/2, your 0.5, because 0.5 can be written as a fraction. Okay, all those things are examples of rational numbers. So rational exponents are really exponents that can be written as rational numbers. So what it really is fractions as exponents. Okay, so fractions as exponents sounds kind of scary. It's actually how I prefer to write my radicals. They really are just an alternate way of writing radicals. Okay? So, if you are taking the nth root of A, it is the same as raising A to the 1 over n power. So what happens is your index becomes your denominator. So, examples of writing as a rational exponent. If I have this, it's going to equal x to the 1/2, because as you remember, if there's no index written, then that means it's a square root, which means my index is 2. If I have, let's say, the cube root of x squared, y to the 3rd, z to the, just z, it will actually become the 2, the 3, the z will be the same, just keep in mind z is to the 1st, and my 3 here will become the denominator. This fraction can be simplified, so it should be x to the 2/3, y, z to the 1/3. Okay. Sometimes you're sort of asked to go in the reverse. Okay. So one example of writing this as a radical, let's say we've got x to the 2/3. Remembering that the denominator becomes your index. And then the x and the numerator are in your radical. I've seen things like this, where you might have x, y, let's say to the 1/4. The only thing with the denominator is the y. So the x is on the outside, the index is a 4, and the y is on the inside. Another example might be something like this. X to the 1/2, y to the 1/3. In this case, they're different indexes, which means they would result in a square root and a cube root. We don't want that. We want one radical. So this right here, what we're going to want to do before we switch is find the lowest common denominator. So the lowest common denominator of each of those is 6. So I multiply this by 3/3 and this by 2/2. I end up with x equals x to the 3/6, y to the 2/6, which would then all be able to fit under the 6th root, x cubed, y squared. So you try. Right, 1 is a radical. Let's just do 2 x squared y to the 2/5. And then write in rational exponent form. Three x y to the 6th z to the 5th. All right, and I'll see you tomorrow.